My name is Bailey Hayes. I'm a CTO at Cosmonic. I am a maintainer on CNCF WasmCloud. I also participate and collaborate with folks like Luke in the W3Cs, WASI co-chair, and at-large director for the Bytecode Alliance Foundation. And I'm here joined with Flynn. He's a technical evangelist for Linkerd. And Flynn, I gotta ask, I've totally forgotten. What does our talk title mean?
Vis Pacem, Adde Rete, which means, if you want peace, add a mesh. It is entirely possible that I might have watched John Wick 3 right before submitting this talk. Yeah, I am a tech evangelist for Linkerd. My job is to figure out how Linkerd actually works and then teach that to people. I am also active with Gateway API and with the AI Gateway Working Group and as a maintainer of Emissary. So I've been doing this a little too long, maybe. Our agenda today, we are going to do a very quick intro to Linkerd because we figured some of you might not have heard of it. Bailey is going to do a somewhat more in-depth demo or intro to Wasm and wasmCloud, and we're going to talk about why you should care about both of these things. We have a demo, really, and we'll show you what it looked like 10 seconds before I got on the stage. It's my fault. It's always my fault. This is the great thing about partnering with somebody who's not from your company. You can blame everything on them. And then we will talk about gotchas and things we want to do for the future. So, Linkerd. Raise your hand if you've heard of Linkerd. Woohoo!
That's a lot of the audience.
We're doing something right. Linkerd is a service mesh, which is to say an infrastructure component that provides security, reliability, and observability uniformly across your entire application without having to change your application. And that last bit is the really critical part for a service mesh. This is necessary because as we work with microservices, they are communicating over a network that is fundamentally insecure and unreliable. These are not implementation details for today. These are fundamental characteristics of a packet-switched network, and you can't change them without completely changing the way the network works. If you don't believe me, go ask the OCI project from back in the 90s, where they tried to do something that was secure and reliable, and the internet is what resulted. Service meshes basically exist to try to make this situation more palatable and to arrange it so that you don't have to tear your hair out to write secure, reliable applications running on an insecure, unreliable network. The way we do this is we take over the network. We stick a proxy next to each pod, like most meshes do. Unlike most meshes, yeah, try saying that. We do not use C++ stuff. We use an ultra-lightweight, ultra-fast Rust microproxy. We take over the world, and that allows us to both mediate and measure all the network traffic that happens in your application, wherever it happens in your application. Doesn't matter where you are in the call graph, doesn't matter what language your application's written in, we get it all. You care about this, or rather, you should care about this, and I hope you care about this, because security, reliability, and observability are not optional. Nobody wakes up in the morning going, ooh, I want to deploy an insecure application. I hope. You have a couple of ways that you can get these three characteristics. You can either get them from a service mesh, which, spoiler alert, that's what we hope you'll do, or you can write a bunch of very tricky application code that requires all of your application developers to get this right 100% of the time instead of focusing on things that actually add business value to your application. You cannot do without them. So that leads us over to Bailey, because I know nothing, I know almost nothing about Wasm.
You know enough because you've touched the rough edges so far, which we'll talk through in our gotchas.
So many rough edges. Yeah.
So
I'm sure that's my fault too.
I don't think it is on this case. I might actually blame myself on that one. OK, so you've heard about Linkerd. You want to use it. And so it's like, all right, let's figure out how to network my WebAssembly. But fun fact, WebAssembly actually doesn't know anything about a network.
That was very fun to learn.
Yeah, it's a portable compilation target. It's supported by many languages, and when you compile it onto a .wasm, inside it, it's really just pure compute. And I can compile from all of these, and if you think about it, compare it to like a portable.exe. Now, if I crack open .wasm, I get this WebAssembly bytecode, and this is called the WebAssembly WAT, the WebAssembly textual format. We'd like to start with W for all of the names of our things. And in this case, I've taken an MCP server for a pet store. So if you want to see if pets are available, you can run this. And what it'll do is when you connect to this pet store, it's serving up the MCP protocol. And when you query for a tool and you say, I want to see what pets are available, it goes out and makes an HTTP request out to a REST API that's a pet store REST API. And so the way that that's wired up is that I have this function import here. So the little insert nubbin is my representation for an import. And then the external nubbin, that's an export. So on the right-hand side, we're taking a look at what it looks like to wire up a component and say, all right, this WebAssembly component says that it needs an outgoing handler. And I can see that I've got these real rich types of defining what a request is and defining what the future response will be. But ultimately, at the end of the day, just think of this as a function handle. And it's a function handle that's wired up for this WebAssembly component that's running on the host. Now, I use this word WASI, and it's come up a couple of times, and I really enjoyed in the preamble to our talk, Ralph giving stories about WASI, so I figure it's worth just like level setting on it. The WebAssembly systems interface, it first came out, the WASI Snapshot Preview 1, it came out in 2019. It also doesn't know anything about networking, and it was built on top of the core module spec, but you could think of it as something that kind of gives you like a POSIX-like ABI that lets you call things when you're running outside of a browser. Really, I think of this mostly as the WebAssembly standard interfaces, because we're working on including more higher-level interfaces, including actually WASI HTTP, the one that we're going to be doing here. So in
Standard library for WASI.
Oh, yeah, say that out loud and clear, because I think that's a really good way to explain it.
When she was explaining this to me, I said, oh, it's like the standard library, the studio library for WASI. And apparently that was a good analogy.
Yes, because a lot of your languages of choice are building in WASI into their standard language libraries. So it's like same. So that's why it makes a ton of sense.
Which is one of the rough edges that I got to experience firsthand.
And if it's not built in, it could be certainly a rough edge. WASI P2, it introduced new networking APIs, sockets, and HTTP. It also is built on top of the component model, and that's where I get those richer types, and that's why you're reading things that actually say, hey, I want to pass in a request here, and I have a response. Now, going back to our example, I've got my pet store MCP server, and I've described how essentially a host would implement WASI, so it would implement WASI HTTP, and it is going to, when it instantiates this component, part of instantiation is making sure that its imports and exports are fulfilled by the host capabilities. But that is just talking about one little box, right? That is, how do I run a WebAssembly component and a WebAssembly host? So let's talk about actually running this in a real environment and deploying it. And for that, I recommend using CNCF WasmCloud for Wasm native orchestration. It allows you to deploy in Kubernetes with our operator. And specifically for this demo, I'm going to be showing you hot off the presses V2 of WasmCloud. I'm running with WasmCloud V2 RC3, which if you like to try it out, all of the stuff that we're doing for the demo is pushed up. Hopefully you're on good network. That is required. And we're going to dive in a little bit.
But Bailey, who is bringing us WasmCloud?
Yeah, who's bringing us WasmCloud? OK, I do work at a company that develops on WasmCloud. But I'm also a maintainer on it. And we have other folks like Colin in the audience here from Adobe and folks from American Express that are all core contributors. So when we talk about building and distributing with WasmCloud, from the ground up, we're built around these open interfaces. And so the whole idea is that you can depend on WASI interfaces, use them interchangeably, and create portable applications from them. But it's important to call out that you can also introduce your own interfaces and build your own hosts and bring them and have that orchestrated within our system. So the orchestrator here is really our runtime operator. This is actually new. We just launched it, I would say about 6 weeks ago. But essentially, the runtime operator is you could look at it and really you can kind of say, okay, I see this image with how we do deployments with containers. So you describe a deployment manages replicas, and then your real unit of compute, like the thing that actually deploys and runs stuff, that's your pods. In WebAssembly with WasmCloud, you define a workload deployment. That's got replicas. And then ultimately, you have a single workload. Now, a workload is not just one component. It's an n number of components and a service. A service you can think of as just basically like a trigger in a lot of other languages, but it has a different lifetime from the components that are running inside the workload.
And you said that the workload deployment and the workload replica and all that stuff are actual Kubernetes resources that you get to go and mess with via kube control and all that.
Yeah, exactly. So they're just custom resource definitions. And this is the example of the workload one. This one's like one of the more simplified ones. In the next slide, I'm going to try to scare you with all my YAML. But for this one, this is the bare bones of essentially what we're going to deploy. And I can say from my workload that I actually need to run on a host with these particular interfaces. That's really important if I want to run something like GPU from my host. In this case, I specifically want to run something that's going to let me serve HTTP. And I also want to call out that you're able to just point to GHCR, aka an OCI registry, and deploy WebAssembly. If you're using an OCI registry, your OCI registry probably already supports WebAssembly metadata. That's something we got done a couple of years back, and it's pretty much. If you're used to running in Kubernetes, this is going to feel same to you.
I forgot to ask this while we were talking about this talk earlier. What happens if your deployment asks for something that the host does not provide?
It doesn't get scheduled. And
Do you
get
see
an
that
error.
in status and things like that?
You get it in the status, yeah.
Excellent. Cool.
Yeah.
Thank you.
There's, if you're able to build your own custom hosts and make your own custom interfaces, it's going to be a somewhat common problem. The whole idea is that the operator is making sure that those workloads show up on hosts that can actually fulfill what that workload needs.
Yeah.
So this is a runtime operator. This is a bunch of YAML that I don't expect you to be able to read. And I'm definitely not going to go through all the different features of our runtime operator here. Mostly, we're just going to be focused on the Linkerd and networking aspects of what you can do with a workload. But it is worth highlighting, just like what you just asked. It's part of how you define your host selection. It can be from a label, but it's also part of your host interfaces that you bind. We do support volume mounts. If you know how volume mounts work in deployments, same thing. Same thing if you want to pass in a config map, you can do config from. There's all kinds of other stuff about like instance pre-warming and pooling and being able to use services to be able to do connection pooling out to databases. We're not going there. We're only here for this one last bit here, which is the allowed host. So when we make a request out from our MCP server out to another host, a type of control that we can add is say, hey, what's an allowed host? Moving on. So when we deploy WasmCloud into a Kubernetes cluster, you often will have many different namespaces deployed. And WasmCloud and the runtime operator are set up so that you can do this in a multi-tenanted way. And the idea is that each team is going to have RBAC controls for each one of their namespaces. So I'm going to have a team in namespace 2. They're going to be able to update their workload deployments just for their namespace and have control over it there. Same thing for somebody operating inside a pet store namespace. And inside this pet store namespace, I actually have more than just WebAssembly components deployed. I also have containers deployed. But as you probably already understood so far, is that I might be defining a custom resource here inside this namespace, but I'm actually deploying it and scheduling it on a WasmCloud host. And those hosts can run in a host group that is multi-tenanted. And I'm able to do that because of the sandbox properties of WebAssembly.
You could presumably also run the host group in that pet store namespace as well.
Yes.
And we get to talk more about that with gotchas later, I think.
Yeah, so being able to control who owns the host group, if I have gold-plated hardware and I only want my special super sauce secret team on it, or I have GPU workload and I don't want random workloads to run on top of it. You have ultimate control there. And in a lot of ways, the principle in WasmCloud for the runtime operator is very much that you own the host. Like, you can build a host, you can provide a host. We don't own that, you do. But when you register it with our operator, we're able to schedule onto it.
I'm going to jump in for one moment
Yes.
and point out also, Bailey was talking about RBAC. So I don't think we talked about this later in the demo. Bailey was talking about RBAC that would control things like whether you could schedule, whether you could put in a workload deployment to a given namespace, whether you could do things like that. But the other thing that we will talk about, that we should talk about rather, is that Linkerd also gets to do Linkerd auth policies for all the communications happening between these hosts, which is an entirely separate layer distinct from the RBAC that we're talking about right here. So combining these two gives you a lot more control than running either of them independently.
And so when we think about how to deploy a component, in this case, I have a specialization of the workload deployment custom resource, which is an HTTP trigger one that defines routes that then another operator says, hey, OK, you're defining a specific host route here. Anytime I see something that comes in on this through my proxy, I will add a host header to it. And that's just managed via Envoy and XDS. I've seen a lot of different types of deployments where folks have Envoy, or they have maybe their own kind of sidecar that they've brought. And I wanted to add that to the mix so that we can show that Linkerd meshes just fine with that type of topology as well.
Yep.
So here, when I crack open a host, inside it, it will have many different WebAssembly instances. Now, that WebAssembly host is just a container in a pod, which means all of your CNI rules apply, all your network policies, all of that applies here. And you can see how I've linked up those function imports to host capabilities, where I've got that one or many PetStore MCP Wasm instances. Those are wired up to the host capabilities for client and HTTP server serving. But let's talk about what the problem is here. And Flynn, I really liked how you described this before, which is, I've got this box, and it's a box of stuff. And to the outside world, I just got a box of stuff that's inside a container.
Yep.
How is WebAssembly different from other types of technology that's got that problem?
See, I should ask you that question.
Nah, I would rather you tell me.
OK, this will be fun, because there are a couple of things that come immediately to mind, and Bailey's totally not putting me on the spot by quizzing me about Wasm. But one thing that we haven't mentioned so far is, one thing that I know is that you can run many, many more Wasm components in one of these hosts than you can run pods on containers in pods. Turtles. Just as I understand it, for two reasons. One of them is that the components get to be really small because they don't have to carry all this common crap around in them. They get to rely on the host for things like standard interfaces, networking, things like that. Another one that comes to mind is that you have more choices in terms of what language you want to write things in and still compile them down into Wasm. I have seen firsthand that, and sorry, let me back up. I've been doing this for a very long time. I've worked with lots and lots and lots and lots of languages. I literally have lost track of how many different ones I've had to deal with. It's been very entertaining to go through and look at Wasm and kind of go, oh yeah, this actually is pretty fast to work with. It comes up quickly. It gives me a relatively native feeling sort of thing, as opposed to, great, let me go write in Lua and then watch how slow it is, and things like that.
And that's exactly the thing that you said earlier that was so intuitive to me when we were working on this talk, was that if you look at this box, as far as Linkerd is concerned, this might as well be a pile of Lua, right? A pile of different Lua scripts or any other type of compute. It is almost a box to you.
Yeah. One of the interesting things about being a piece that grabs, that intercepts the network, is that what we see is whatever happens on the network. So we don't care what language you're using, what runtime frameworks you're using, whether you're a pile of Lua scripts or a pile of Wasm components, whether you're an Envoy, whether you're a monolith that somebody just decided to run in Kubernetes. At this point, we don't care if you're running it on a Windows node, and we don't care if you're running it outside of Kubernetes even, some of which we will talk about and some of which we won't. But arguably should have.
Yeah, yeah. There's enough to dig into. So,
Yeah.
triply fingers crossed on this demo. I was having some network issues just a second ago, and I switched everything to my phone and tried to reconnect it all, and it wasn't really working. It looks like it's still not working. So what I'm going to do is walk you through what we have deployed. First things first, if you want to install Linkerd into a WasmCloud deployment, it is one command. It is that command.
She's even doing it the hard way.
That is technically the hard way. The easy way is to just do it on your whole namespace, right?
Right. The easy way is you just annotate the namespace and tell Linkerd, hey, any pod that shows up in this namespace, just mesh it. And I think that would work, but
I just paranoia.
Yeah.
I know what I want to mesh, and it's that one.
Yeah.
And so that's basically specifically adding.
Ooh, we should have written down that there's a future thing to try.
Oh, yeah, okay. Yeah, we've got a list. We've got a good list. The first thing I do want to walk you through is kind of demystifying a little bit more on the, what does it actually look like to write code that uses WASI HTTP? In this case, I'm using TypeScript. A lot of folks don't realize that you can also take TypeScript and use bytecode alliance tooling to take that TypeScript and get it bundled into a .wasm. So if you look at my little package.json here, there's this build called, oh yeah, can you guys read this?
A little bit more.
Make it bigger. Okay. So here we go. Is this big enough?
One more.
Una más. All right. So JCO, the JavaScript component tooling. What I'm able to do is basically take TypeScript code, and I run the TypeScript bundler, and then I take the basically that bundled code and take that JavaScript bundled code, and then I componentize it. And I componentize it by adding in a JavaScript runtime called Starling Monkey, which is also in the Bytecode Alliance. But essentially, blah, 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 out comes a .wasm. And that might sound scary and strange, but if you just go to Cosmonic Labs pet store MCP server and run washdev, you too will be able to build this pet store. And the code for this is also not scary, I promise. If you go into source routes v1 MCP, go to the tools. You can just look at some of the available tools. I'm going to play around with the one that I know that I just ran a few seconds ago before things went haywire.
Came to an end.
Yeah. So this should, if you're familiar with TypeScript, which I am not, I am only dangerous.
It's possible that Bailey Vibe coded this whole demo as well.
It's totally fine. So I got help from my friends. Victor and Mindy, thank you for helping me do actual TypeScript. So this is using the Model Context Protocol SDK. So that's just straight off the shelf. It compiles down just fine into WebAssembly, so I'm actually able to use all of those existing types. I was told I needed to be cool if I'm doing anything with actual typed things in TypeScript, and that I should use this thing called Zod. The TypeScript ecosystem, it really sends me sometimes, but I hear that I am using the hippest, latest, coolest tools to be able to build this, and that if you look at the source code, it is completely idiomatic TypeScript.
Which is awesome.
And you don't see anything here that is WebAssembly WASI crazy nonsense that you don't know what it means. And that's the whole point, right? Is that you can write idiomatic code today, compile it to a very efficient bytecode format, and then deploy it. So let's look at the deployment side. In theory, I've got things deployed in Kubernetes, and then I've got them meshed, and then I ran against it, against what I was running in my mesh, and I ran a tool call, and notice that I'm not running things because the network has been down for me. I ran a command called get pet find by tags, and I was looking for pets that had already been trained because I don't have time for potty training right now. And I found one dog whose ID was 123, but it's got a cute dog name. It's named Max. And so if I then plugged it up to an LLM, which I was totally testing to make sure that nobody had added strange names or anything to the public pet store swagger.io REST API that I'm calling out to. And I asked this LLM, hey, give me some available pets that are trained. It went and knew to use that MCP tool. And it's super easy to install these and turn them on and off. If you haven't been playing around with this, I totally recommend trying this out with Goose, because it actually gives you really good errors when things are happening or not happening.
Bailey, can you zoom in a little bit on that
Yeah. Maybe?
Just to sort of give a better idea.
Yeah. Well, no. Sorry, Ralph.
Okay.
I did try. But this URL is the same as this URL. That's the TLDR. In the chat, it was able to successfully find good old Max.
And in both cases, the URL is supposed to just resolve to localhost because it's set up so that she can talk to it on localhost port 80 and do sane things when the network is sane. Thank you.
Conference networking.
Thank you, network. Yeah.
Now, what I also ran, because we've successfully meshed it, is that I ran it with Linkerd. And Flynn, I know we're getting tighter, so.
Yeah, so there are a couple of things in this one. This is the Linkerd Viz dashboard we are using for this talk. The completely open source normal Linkerd from CNCF as opposed to Buoyant Enterprise for Linkerd. Everything I'm about to say works in Buoyant Enterprise for Linkerd as well. This is sort of the overview that you will see if you go to this dashboard in the first place, just to go and show you an overview of what is being meshed, what is not being meshed, and to give you a quick look at golden metrics. So if you look, whoops, if I hit the right button.
There it is.
Yeah. Here we have a bunch of namespaces. This column is how many things are meshed versus how many things could be meshed. Come on. Requests per second. Sorry, success rate, requests per second, and latency, just all there for you to go and look at. The most interesting thing to me is that Bailey was paranoid, which is why only one thing out of the 10 in Cosmonic system is meshed. So we'll work on that. But the one thing that's meshed is, in fact, the host group that Bailey was describing. So the thing that is allowing all of the Wasm components to do network traffic is the thing in the Cosmonic system namespace that Linkerd is allowed to go through and mediate and measure. And so if we were to go through and drill into this, which I'm kind of afraid to do with a network that's not working, but let's see what happens.
Oh, no.
If we, yeah, well, okay, that didn't work. This might now just completely, I really shouldn't have touched it. But if you do go through, when your network is working, thanks, network. When your network is working, if you drill into one of those, you will get a list of all the deployments in there. You'll get a nice little traffic graph of who's talking to whom. You will get further information where you can look at the golden metrics for each of your workloads. You can drill further down and see, oh, look, this TCP connection is indeed meshed. It's MTLS. This one over here is talking to some crazy thing. It's not meshed. It's not secure. So, oh, hey, there we go. Don't touch anything else.
Just kind of kicking it. See what happens.
But yeah, so there's an enormous amount of information that Linkerd can give you solely by meshing the host group, because at that point, Linkerd gets to see all of the network traffic that all of the Wasm components are doing. Yeah, okay. So the host group is meshed. We could click on that one and maybe see who it's talking to. It's not talking to anybody right now because the network is down. But if you scroll up to the top again, so we can see that the Prometheus server is talking to this thing to go and do all this metrics gathering. There should be other boxes over here that the host group is talking to. You should probably be able to see the Ingress controller talking to the host group if this were all working properly. If you scroll down to the bottom, then you can see, this is a little bit interesting actually. So I have no idea what Nexus is, but
That's our operator, yeah.
yeah. So those aren't meshed, and so they show up with scary little warning things.
Nice.
And so
that's why you want me to mesh the whole namespace.
yeah,
I get it.
and then here,
Public shaming.
we get to go through and see that the other ones are meshed, and so they have happy little green check boxes.
Awesome.
There is an enormous amount more stuff that you can do with Linkerd that we did not do in this particular demo. The most obvious one would be things like we could put in authorizations so that, for example, the tool that she was using would be allowed to go and, talk to the find a pet tool, but not talk to the adopt a pet tool or something along those lines, right? So there's a lot of stuff that can be done there. There are also some gotchas that we have to talk about. The biggest one, absolutely the biggest one, is the wasmCloud control plane at this point relies on NATs. NATs is a server speaks first protocol. Server speaks first protocols are the root of all evil. So you have to mark them as opaque in Linkerd, because otherwise, every time you make a new NATs connection, Linkerd will sit there for 10 seconds waiting for the client to talk so it can figure out what to do with it. It'll work after that. It's just slow and annoying, and nobody likes it. The really good news here is that if you forget to do this, the failure is not subtle. You will know instantly that something is wrong, and you'll be able to fix it. This is arguably an area for future improvement. It would be nice to go ahead and add some more stuff here. The other one is, right now, all the Wasm components are within a single host group, and the single host group is the thing with a Linkerd identity, which means that they all share an identity, which is a little interesting. We're working on that. Also, Wasm apps are sandboxed. This is generally not going to be a big deal, but if you're coming to Wasm from some other sort of ecosystem and you're used to being able to do everything you want, Wasm might confuse you until you internalize this. That totally didn't happen to me. This is generally a good thing. It's just a thing you have to be aware of. And we're actually out of time, so let me do this really fast. Future stuff, yeah, we really want to give individual components their own identities. This turns out to be very tricky. There are a couple of different ways we could approach it, so we have to figure out something like that. That'll be fun to play with. I also mentioned Windows and things like that. Linkerd actually has the capability to mesh both things in Kubernetes and things running on Linux. Actually, we can also deal with Windows nodes and things like that now. And if one of those things running on a Linux box outside of Kubernetes is wasmCloud, it should just work. And so we're both looking forward to trying that. I'm sure there will be something that gets in the way, but we've done a fair amount of stuff like that. If this sounds interesting to you, come and talk to us. We'd love to hear about that.
Yes.
Also, we just announced Linkerd support for MCP. Sign up for the early access. It'll be cool.
So if I was running the enterprise thing and they let me into their thing, I have to get that in.
Yeah.
Then I can show you some greater observability with MCP.
Yeah, it's wicked early at this point. So, but it's still pretty cool to watch and see. So we are out of time, so I guess that if you have questions, come by the Linkerd kiosk tomorrow, or where are you going to be?
I'm going to be at the Cosmonic booth all day.
Be at the Cosmonic booth.
Every day.
Come by, talk to us. Thanks for listening.
Thank you very much.
Whoa, nice cat.
All right. We got 5 minutes while David's doing that. Does anybody have any questions about how all this works? About why the font was so small? No, that's my question.
Anybody?
Okay. So if you have 5 more minutes, you get that network going. I want to see live, man. Get the network going.
I'm kind of tempted. I mean,
Because the network should work.
well, we kicked
course
it.
it
We
should
kicked it
work.
again, and we actually got some success. So
Yeah, I saw numbers actually changing.
we're still down for some other reason. I think something failed to pull.
Oh, okay.
Yeah, well, we'll have to sort that out, and
Everything's
hopefully
fine.
we'll be able to see that.
I'm sure.
Fire that up at the Cosmonic booth.
Yeah.
No, you demonstrated the point, no question. But it's always fun to try and, if you have a few moments, it's always fun to see things working.
Redemption around,
Yep,
yeah.
It's much
absolutely.
more satisfying to have it actually,
Yeah.
to actually do it live.
So I do have one question about the control plane. So if you're doing RBAC, so just to be clear, so you've got Kubernetes RBAC based on Kubernetes resources, and then in Linkerd auth and authorization, you have RBAC there, which means, so the distinction would be so you can set the Kubernetes policies, but then you can set networking policies.
There's 3 different things that we're kind of conflating here. One of them is Kubernetes RBAC controlling which resources you can manipulate. And so that would be, in this namespace, Bailey is not allowed to, actually, Bailey would be allowed to create workload deployments, and I might not be able to, because she's not going to let me touch that would be bad. Another thing that you're talking about is Kubernetes network policy. That happens at a lower level than Linkerd, and so Linkerd's authorization policies compose with Kubernetes network policies.
Okay.
Now, bias. I generally am not a fan of using network metadata as any part of authorization, because I don't trust the network. That's why I like to do it all up at the application level cryptographically. But they compose just fine. And there are a bunch of people out there who will do things like, oh yeah, so these two things, we've got a network policy preventing these two namespaces from talking to each other, or things like we have a network policy preventing this chunk of the cluster from talking to this other cluster over here, which Linkerd will happily serve for multi-cluster stuff. But then you can also do much finer grained things like this workload is allowed to make a given request of that workload, but it cannot make any other request of that workload. So we get to do very, very fine,
super fine-grained stuff at the application level, where you're sitting with knowledge about how to control that specific end-to-end request that has nothing to do with the lower layers or what networking is going on.
We can also use that sort of capability to do things like A/B testing and canary rollouts.
Right.
5 layers deep in the call stack, whether you're close to an Ingress controller or not.
Okay. Thank you very much.
Pretty cool.
So if there's one point that I want anybody to take away, is that while it might seem weird and strange and different, it's actually just HTTP networking at the end of the day. And you just plug it up and it just works. And when you write your code, it just looks like regular HTTP client, HTTP server code. Please don't be afraid. Give it a try today.
Thanks again.
Thank you.